Okay. Great. Okay, Dr. Blackburn, thank you so much for being here with us. So I wanted to start by talking about your childhood. Can you just tell me about your upbringing, a little bit your family structure?
Well, I was brought up in Tasmania, Australia. Tasmania is the island just off the south of Australia, part of Australia, and so I grew up in a fairly small town as one of 7 children. I was the second of 7 children, and my parents were both family physicians, so my mum only practiced part-time, as you can imagine, with a big family, and so I grew up, in this fairly small town in Australia, and I always was very interested in animals, and quite liked my schoolwork, and got interested in science as I went through grade school and into middle school, and particularly got interested in biology, and partly I think that was because I really did like animals a lot and was very curious about how did biology, how did life work. I really liked animals when I was a kid, and when I was very, very small, my mom tells me I would pick up little dangerous creatures from the beach, like poisonous jellyfish or dangerous ants that sting you, when I was, just a little kid. And then when I grew up, we had a house and a garden, and we had all these animals, and I just loved the fact that we had, cats and often a dog and budgerigars, canaries, guinea pigs, rabbits, bantams, chickens.
Was it unusual for a girl living where you lived in the time when you grew up to have those interests?
I think it was unusual to be interested in animals, which was brought home to me by when I tried to show my guinea pigs' newly born babies to one of my little classmates, and she was just horrified when I opened my cupped hands up and said, look at these beautiful little guinea pigs, because they're born fully formed and fully with fur, and I thought they were just the cutest thing around, and she was just horrified at how, ugh. So I realized that, my interests were not necessarily shared by other girls in my class.
When did you know that science was your passion?
I mean, I liked science partly because I thought it was sort of a cool thing to do. I thought chemistry classes were very interesting, and I didn't want to necessarily be a chemist, but I could understand that was the kind of precision and thinking that you could bring to any kind of science, and I just assumed that would be the case in biology as well. And definitely there was a fascination with living things, how did they work? I remember reading some very influential books when I was a teenager, and these were books about, what was life, what were the molecules of life, how did it work, how was the genetic code working, which was not very, very well understood when I was growing up. And that was just, very captivating to me, that there was something, intellectually interesting about it, and also it was about living things, which fascinated me.
Was it mostly books, or was it that life experience, or both?
I think what got me interested in science was a combination of things. We had lots of animals at home, and I really liked nature, and was, kind of very, much as a teenager, as you look at nature and you're very impressed by it. And then I read certain books which in part were about science, but also books about people, very influenced by the biography of Marie Curie, which was written by her daughter. And I read that in middle school or high school or some stage like that, and I was very, very struck by her life story, and particularly sort of her dedication to science, and this idea that there was this wonderful thing called science that you could identify with, and you saw this as something going beyond yourself. I found that very, very interesting, and it was captured very well in this biography, which very much as a child I was reading.
Tell me about your decision to leave Australia and come to the US.
Well, my route from Australia to finally ending up in the US consisted of, first of all, doing my PhD in Cambridge in England. And that was something that at the time, which was in the early 1970s, that was something considered as really quite an important part of your education in Australia if you're going to go to higher degrees or go into academic or research, which I had decided by then that was what I was going to do. It was figured to be very reasonable to go overseas somewhere. And so there were possibilities to come, to the US or to UK. Those were the choices that I was looking at. And I decided to go to the UK partly because it was a more familiar setting, and then partly because, very frivolous sort of thing. I remember one of my undergraduate research advisors telling me that he said he finished his postdoctoral time in New York. He was at Rockefeller, and he was getting all his books out, and they were completely covered with black, soot and so on from the pollution in New York. And I thought, I can't go to New York. Right? So the other place I was considering was Cambridge, the MRC lab, the Laboratory of Molecular Biology in Cambridge, which was a great centre then for molecular biology and protein chemistry, which was at the time what I had learned something about. And so Cambridge also struck me as a very attractive place in terms of, I was told there was very exciting science going on there. So I was given good advice about places to go, and was pretty influenced by that advice I was getting from my undergraduate advisors. After I'd finished my PhD, and then there was a question of, well, where would I go? And coming to the US was a very natural thing to do, because that's where I really felt that you had possibilities to do science. And especially, this was in the mid-1970s, I really felt that as a woman I'd be able to thrive there. I didn't think that women would thrive especially well in the UK, the British environment, or particularly well in the Australian environment. I'd love being a student in the UK, but I didn't see that was going to be a place that you could really, easily thrive in science. And my sense from the US visitors, people who were at the MRC lab and visiting Britain or doing research in Britain from the US, was where there was sort of the dynamism and the, where a lot of exciting science was happening, and where people, women could thrive. So I was very influenced in that, and for me, going to the US was a very natural next step. And then the question was where, and so I originally applied to come to San Francisco, and it was all arranged. But in the meantime, love intervened, right? And so my now husband, who wasn't my husband then, but we had, a relationship, and so I decided to go to the same place he was going to go to, which was Yale University, and so I looked at possibilities there, and again, getting good advice from people, I identified Joe Gall, who is a very good scientist, superb scientist, and also was known to be sort of a good mentor of people as well. And so that combination of things, was what motivated me to apply to work in his lab as a postdoc.
When you got here, did you ever encounter sexism, or did you feel you were hitting up against a glass ceiling?
I noticed that that men and women were in very different situations. When I became much more in a what would be regarded as a more senior position, and so here I was at the university in a big medical school, and I remember I was appointed chair. We had rolling 5-year chairmanships, and so I was appointed chair of my basic sciences department. I remember negotiating what that would mean, and not doing a whole lot of negotiation, which I think was, I sensed at the time it probably was a somewhat gender-specific thing, but it was fine enough, I thought. And then I had this moment when I went to my first medical school chairs meeting, and I went into this room, and I was the only woman chair there, and it was this funny feeling. I had this absolute flashback. I'm back in the 1970s. It was really, really strange, because suddenly here I was in a situation that I had forgotten was so common back then, which was to be either the only one of very few women in a room of scientists, or people who you were talking about science with or going to a conference with. They were very predominantly men when I was starting. So it was a sudden flashback that things have not really changed all that much.
What was the next feeling after you felt that I'm back in the 70s? Was it, I'm just going to ignore it, or this is maddening?
Yes, that's right. Back in the 70s, I really felt that that was something that wasn't, it was going to change, was my feeling, that there would be more and more women in science, and particularly I felt, well, this was something that, I was doing science, and that was my main preoccupation, and I was somewhat willfully not really paying a whole lot of attention to these issues, realizing they were there, but choosing for whatever reasons of self-defense or otherwise that wasn't going to be my preoccupation. But then as a departmental chair, then I realized that no, these dynamics were, these were very real, and now these were affecting things in a very different venue in some ways from the science itself, which was always somewhat of a refuge, if you will, in some senses from this. But now I was being a chair, and so I would have to start, really functioning in this manner. And so, that was challenging, I found. And I think it remains challenging for women in these kinds of settings. But I learned interesting things that, I learned, what good leadership looks like. And so it was very worthwhile to be doing this. But one also learns that there's a lot of stuff that has to be done when you're taking on administrative responsibilities. And my sense was this was important, but my science was also very important to me at the time. It coincided with when the science was going, very full tilt. And so I found myself, while I was doing chair duties, I was thinking, well, okay, when can I get back to the science? While I was doing science, I never thought, oh, when can I get back to the chair duties? So that, was pretty much telling me where my true interests lay, even though I realized, how important it is to have good leadership and how important it is for women to be involved in that. At that point, I could also read myself and see what I really thought was what I was passionate about, and I liked the chairing and administration in some ways because it was interesting and challenging and worthwhile, but it wasn't, where my passion lay.
But was part of it motivated by feeling called to duty as a woman in a high-profile position?
Yes. A definite part of accepting being a chair in a department in a medical school was that there were very few women in such chairing positions, and by then I had realized that it was very important for women to be seen, and the word role model is used, and I think that's very valid, that to see people doing something makes it less unlikely that then more people will do it. And in fact there was another chair, a woman chair in the School of Medicine when I began my chairmanship, and I'll never forget because I rode in the elevator up to some chairman related meeting, and my colleague said, well, I think I should tell you I'm stepping down from the chairmanship in a couple of months. So we were two chairs in the entire School of Medicine for a short period of a couple of months, and that was it. And then it went back to one again, which was me. And then when I rotated off being a chair, then there was by then another woman chair in surgery, interestingly enough, which is not a stereotypical department for a woman to be a chair of. But here it was in this very large medical school, one and at most two women chairs. So the disparity was extremely clear to me, especially given that we had equal numbers of higher degree students, PhD students, medical students, postdoctoral fellows who were women compared with men, and yet look at what was happening at the full professor and chair positions, where the women were very, very much fewer. So it was very clear to me that there were major issues in terms of what was happening to women's careers.
Why do you think that happens if there are so many women getting PhDs?
There's a very clear discrepancy between the fact that there are equal numbers of women, at least in the biological sciences, in the PhD level, and also at the postdoctoral fellowship level, which is this very important career stage before one can launch into later, stages of independent research positions or faculty positions. And then the discrepancy is with those equal numbers compared with the very few women who are in, sort of the more senior advanced positions. That's still quite low, even in the biological sciences, and I think lower in other kinds of sciences, and also in positions that are regarded as leadership positions, such as departmental chairs and so forth. And so the question is, well, where does the drop-off happen? And so what I see currently is that it's happening at the stage after the postdoctoral period, And that's where, there's all sorts of ways these numbers have been collected. But for example, I see it when I serve on selection committees for new starting independent assistant professor positions in our institution. And this is typical, not unique to ours. And so what we see is that the number of applicants now is not 50-50 anymore. So there's a huge thing that's happened here. And so we have to say, well, why do women find it so repellent to apply? What repels them from applying, right? And so we have to start thinking there must be something really about either the way the jobs are and how people perceive the jobs are, and how women feel about throwing their hat into the ring and applying for positions in fairly demanding research universities such as the one that I'm in. And so here I've seen men and women performing equally well, and then this big change. So we know that there are dynamics there, such as people are very concerned about, the career structures and where can you have a life in there. And I think this is something I hear over and over again, and it's a justifiable real concern, which is how am I want to have a family, and how am I supposed to do this when you're supposed to be, working incredibly hard. And so what I think we've failed, we meaning a very collective we, is we've failed to say, well, how can we be creative about having women, continue? And so institutions have done things, tenure clock holds, childcare leaves, things like that. They do them, but the culture is very much still that women feel, disadvantaged if they have to ask for such things, as though somehow this is putting them on a weaker footing. And I've seen that reluctance because, and it's true, it is made difficult for women. Not so much overtly stated, but tacitly, that it's harder for women who are now not 100%, producing, if you will, in whatever some external mnemonic or an external sort of way of counting is. And I think that's a big mistake. And I've seen examples where people I've known, and they haven't always been in the US, have, wanted to have families, have been part-time for a while, or sometimes that while can go on for quite a while, and then very successfully come back into full-time positions. And I know cases where this has happened very successfully in Europe, in Australia. People I've known from my contemporaries in Australia, that was how some of them had their career structure, which was to go part-time, and then the system was such that they were able to come back in. And I think because they were very good scientists and kept their research going through various sorts of devices part-time. I think we really have to rethink how we imagine careers for women in science, because the current way is a very much one-size-fits-all kind of career structure, in which if people deviate from a completely full-time model with a certain sort of trajectory, then they're regarded as not functioning properly as scientists or competitively as scientists. And so we lose very good scientists because we don't have just a more imaginative way of thinking about how careers can work.
Can you give me a sense of how much a normal young scientist on the sort of cusp of their, discovering something or really into their research, how much do they work, or how much have you worked at a certain point in your life?
So people often wonder, well, what kind of work does it take to be a scientist? And it basically is in waves. So there's very intense times, and then there are times when experiments are going on, and just the nature of the experiments. It's not necessarily 100% of the time, although you're probably having your time taken up with administrative and other university and ever more bureaucratic impositions that seem to happen these days. So the time can get filled up, but it's not always with science. So one can be very, long hours working, but it's not all related to science, and it comes and goes. So there are times when, you can be working very long and intense days, because that's the way the sort of trajectory of the experiments is going. And then there'll be times when, your timetable is under your command. Now, often, of course, you're very limited by your experimental material, and you're having to go along with that. But it's hard to put it into actual hours per week, because not all of the hours per week are actually engaged in science. A lot of them are engaged in, say, institutional requirements or bureaucratic requirements. So the interesting thing about doing research is that a lot of it has an inherent degree of autonomy to the person doing it. You can actually, for many kinds of science, choose your trajectory of time, and one can be quite productive in part-time settings without diminishing the commitment sort of to the intellectual and scientific thrust of what one's doing.
So now to talk about your work.
Well, my research is on telomeres, which are the ends of chromosomes. And so if we think about chromosomes, which carry all our genetic material, and they're made of DNA and associated proteins. If we think about chromosomes, by like a metaphor, like a shoelace, then the telomeres are the little protective tips at the ends of the shoelaces that, you can think of as stopping the ends of the shoelace fraying away. And literally the ends of the chromosomes are very important because if they are, weakened in any molecular way, then they stop protecting the genetic material, and cells will react to that by ceasing to be able to replenish themselves, for example. And so what happens with telomeres is they have a natural tendency for their DNA to dwindle away and get shorter and shorter with time. And so that has a tendency to make cells eventually stop dividing. Now, what we discovered back in the 1980s was an enzyme which we called telomerase, and that makes the telomeres longer. It actually adds back telomeric DNA. And so now there's this sort of constant sort of push-pull of the telomeres getting longer and shorter, and basically the whole dynamics of that race going on in all our different kinds of our cells is turning out to have very interesting implications for how long, our tissues can self-replenish throughout our lifespans, for example. So when the cells can't replenish themselves, then that means tissues can't replenish themselves. And so we see it played out, for example, when the immune system starts to fail in bone marrow, production of immune system cells fades away. And if you don't have enough telomerase through just inborn errors of your genetic material, rare mutations that happen in unfortunate individuals, if they just have half the amount of telomerase enzyme that they should have, then over their lifetimes their telomeres dwindle down too fast, and they basically die of various diseases, prominently of progressive bone marrow failure, so they can't fight off infections. But actually they're also cancer prone, and they're prone to fibrosis in the liver and the lung and various things, all indicative of cells not being able to keep replenishing throughout life as they should be doing. What's important about research and what, the things that one finds? And I really think of it in two ways. I mean, one is that just finding out how life works, to me that's incredibly important. It's a little bit like finding out, well, what does the universe look like? Does it really matter what's happening in these galaxies? I mean, honestly, how practically is this affecting our lives? And yet we're really interested in that as just as people. We really want to understand how things work. And really the main motivation for my research over many, many years was all about that. I really wanted to understand how nature worked. And it was the process of finding out, which is like solving puzzles and trying to second-guess nature and then think of rigorous ways of testing it. That was the great fun of doing science. And then in more recent years, as the science has moved more and more into being able to study things in human bodies and human cells, it became clear that this running down or wearing down of the telomeres is something that we can see that's being played out in ways that look as if it's affecting the chronic diseases of aging. So as medical science has solved many problems of human health, infectious diseases, broken legs, medical science is terrific at lots of things. But that's laid bare now some of these other more chronic diseases, which tend to be the ones that kill much of the population in middle to late age, such as diabetes, cancer, and cardiovascular disease. And those big killers are very influenced by the ability of telomeres to be maintained in the body. So the research has become interesting to people because now we can sort of see more and more, clearly, lots to learn still, how this is relating to quite profound issues of, how we continue to live our many decades of life.
Can you tell me about the moment and when you realized that telomerase did what you thought it did?
The way we found telomerase was, there was probably a few eureka moments, right? There was certainly a couple of eureka moments when I was, throwing every DNA into the pot and seeing whether I could see any evidence of something that was adding telomeric DNA to either telomeres that existed or even telomeres that were going to be formed from where there were no telomeres before. So I was doing these very sort of, speculative experiments early in my career, but I had tenure after 6 years at Berkeley, which was where I was doing the research. I had tenure and I had NIH funding to explore the general questions of telomere function and structure. And so this was, very good funding because it basically said, go find out, figure this out. The best kind of research funding that you can think of. And because it didn't specify every last little, detail. It said, go out and do something interesting. And so I felt I had this ability to start doing experiments. And so I remember, a very early one was starting to see some evidence that over time there was building up more and more of this new DNA sequence that was being synthesized in the test tube by something inside cell extracts. And so I'd started these experiments very much, throwing everything but the kitchen sink into the reactions to try and get cell extracts to produce telomeres. And then clearly, a hint is not good enough. And so then I was joined by a PhD student, Carol Greider, with whom, together with Jack Szostak, I shared the Nobel Prize. And so, and I told Carol about this project, and she said, this is the most interesting project in the lab, and this is the one, I'd like to work on. And so then she, then really started working very hard and getting the reaction to work. And at some point, we made a couple of crucial decisions, which was to use a different kind of way of visualizing the DNA that was added onto the ends of the artificial telomeres that we were putting into our enzyme reactions, in the test tubes. And this visualization made it very clear that the DNA sequence that you were looking for to be added to the ends of chromosomes was being added on. And so Greider had got the result on Christmas Day, showing that there was a pattern that I had expected to see for a telomeric DNA sequence, that we knew what the sequence was, because I determined the sequence some years ago. I knew what the sequence was. And there was a pattern we expected to see. And we saw that on the autoradiogram of the radioactive products that were being synthesized. And so we knew that there was something there. And so, I think we both had this strong sense this was very likely to be it. And then we spent many months, trying to think of every experiment that you could to try to deal with what possible artifacts might be causing this, and you were just deluding yourself, right? So, one day Carol would think of an experiment and, some horrible possibility, and we'd sort of try and design some way around, and then sometime a few days later I'd think of some horrible possibility, and then we would try and design some way of addressing that possibility. And gradually, one by one, we eliminated all the kinds of possibilities that rationally you could think of that could be accounting for this result that wasn't this new, enzymatic activity.
How did that feel at that moment when you said, we've got it?
Well, I think the realization that we really had the enzyme came in several stages. There were certainly stages when we'd get a particular result, we'd see a pattern, and we'd say, aha, this looks like this is the right thing. And then it was more like chipping away at all the different sorts of possibilities until more and more we got to the point we said, well, okay, we can write a paper now and submit a paper on this research. And by then, I felt pretty confident that we really had something. And in fact, the reviewers only came back with one small experiment, pretty much, to do, and we did that quite easily. And I, was able to do some chemical procedure which worked to just sort of cross an I and dot a T in a way. Life doesn't happen in just one moment. It happens in incremental aha moments. So there was a series of incremental aha moments, and they just slowly became more and more solid.
In 2009, you won the most prestigious award given in science. What was it?
Well, in 2009, I and Greider and Jack Szostak shared the Nobel Prize in Physiology or Medicine. And people always like to hear, well, how did you find out about this? And so I found out at 1:55 a.m. on Monday morning in October, early October, when I received a phone call very early in the morning. And I have to say, I was not expecting that this was going to be this wonderful phone call. And usually when you get phone calls at that hour in the morning, you expect this bad news. Actually, we'd just been visiting my 95-year-old mother-in-law then, and down in Los Angeles, having a sort of family reunion. So, I must say, my first thought was, "Oh dear, we've overdone it, and maybe something's happened, and we've exhausted her or something." And so I was very happy when I got the phone, and a very Swedish voice told me the good news. And then he said, "I advise you to have a cup of coffee, because the media are going to be there within minutes." And he was right. And then nothing stopped for about many, many months after that.
What was your reaction to receiving it? Had you expected it?
I'd heard rumors every now and then over a few years. And so I hadn't especially expected it because, I'm not that old and there's lots of good science going on. So I'd sort of heard this, and I thought, well, that's wouldn't that be exciting kind of thing? But it wasn't like I was particularly expecting this phone call. And as I said, I was actually expecting when the phone rang, what leapt into my mind was a very different kind of phone call.
What does it mean to you that only 10 women have won this prize?
Yes, very few women compared with men have won Nobel Prizes, and so it was particularly, I thought, gratifying the year, in fact, that I was one of the Nobel laureates. So was my former PhD student, Carol Greider. We got the prize together with Jack Szostak, and another woman in science, Ada Yonath, won the prize, shared that in chemistry, and a woman shared it in economics, and a woman received it in literature that year. And so that was an unusual year for Nobel Prizes. Now, the numbers are small in any one year, so fluctuations are to be expected. But given the fact that very few women, considering the many hundreds of Nobel Prizes that have been awarded, the fact that very few have been women, I was thrilled just from the point of view of, again, once somebody sees it happening, and then they can think, well, this could happen to me too. And I think this has had that effect. Many women have said to me that this has meant something to see us winning Nobel Prizes. And particularly, as I said, this year of 2009, there were 5 women who got various Nobel Prizes.
Your research today, what is the goal and where is the research right now?
Well, in biology, things are always very complex, and the more you look, the more complexity you find. And also the more, depth you get in understanding something. So this is true for telomere research and telomerase, and so our research very much focuses still, although not entirely, but still on really trying to understand how telomerase does its job and how it works with the telomere to protect the chromosome ends. And while in very crude outline we've known this for a while, there's a lot of it we actually don't understand, surprising gaps in our understanding, which of course makes then for a very exciting, interesting research still. The thing that's grown out of that kind of question, which was the original science that I was doing, has been how does this relate to issues of human health, particularly as we look at the particularly major diseases that are the emerging problems, in fact, worldwide, as we being the medical world, solves many of the very acute medical problems. And I'm not saying they're all solved, but what is becoming clear is that we have to really think about the diseases of middle-aged aging populations, which are much more chronic diseases, and for which medical science has actually not done a great job in preventing or intercepting early. So a lot of my research is now, in addition, collaborative research, where we collaborate with clinicians, doing various studies, trying to understand how we can anticipate and how we can alleviate some of these processes that are going on where the telomeres are running down, and that's leading to increased diseases of aging. The major diseases of aging that we know are affected quantitatively by having inadequate telomere maintenance. They include diabetes and certain cancers and cardiovascular disease. Now, those happen to be the three major killers of the elderly in developed populations, and so this is not a trivial question. And not only the major killers, but the morbidity and the huge disease burden that these things cause. This is a large problem for humanity, and not just in developed countries either. This is really worldwide. These are the things that are the big issues. In addition, obviously, to the more severe childhood and other diseases, and of course we still have some major diseases such as HIV worldwide, and yet our research also touches on some of the HIV questions as well. So I'm very interested now in the collaborative possibilities that we bring our expertise on telomeres and telomerase, and our collaborators bring expertise in various aspects of diseases and medicine.
And what is the end goal in that?
I think if we really think about medicine, the real end goal is prevention, right? Right. Better to prevent a disease than, or to intercept it very early, than to let it run its course and then run around like, a fireman racing to a house on fire. The house is on fire. You're going to put the fire out, but there'll be a lot of damage. And, let's try and preserve the house from day one. So that's where I think the science can go. And what we're finding is that as the telomeres shorten, in some ways there's sort of a warning of risks of diseases to come down the line. So that has put me very much in the way of thinking about how this research we're doing can play into that. It's by no means the only factor. Nothing is one factor in biology. But we do see this really underlying, in such a prevalent way, a lot of these insidious diseases, which are the chronic diseases in so many societies. So I'd like to see that being used for that, forward-looking goal. Let's not just treat the diseases that exist, which of course is important to do, but there's lots of activity. But let's try and look ahead and get ahead of the game and try and think much more ambitiously about prevention.
If your research continues to progress, could we prevent the diseases of aging eventually? Is that the ultimate goal, to harness that power?
So one question one might ask is, can we prevent diseases of aging? Because we see that inadequate telomere maintenance contributes to diseases of aging or developing, as not even people getting that old. I mean, this is something that can start in adulthood onwards, and so I'm not sure that we can just simply prevent it. It's not sort of some magic pill or something like that. And I also don't think that our lifespans are necessarily determined only by this. There are clearly a lot of genetic inputs into what determines our maximum lifespan. However, what's more important is how healthy is our life until we die, which is somewhat genetically determined. The latter, when we die, the maximum lifespan has probably got a lot of genetic determinants in it. But how healthily we are living until that time is something that it looks as if the telomere-related research does relate to, and that is if we can think of ways that we maximize the action of telomere maintenance, and that might mean, making sure that the telomerase enzyme is as active as it can be, with or without pharmacological intervention. Then perhaps we can really minimize the time that we might end up in our lives getting these diseases. So if we can push them away further and further by maintaining telomeres, then that would be a wonderful aim. But I don't know if we can do it entirely by doing that, but we know that that would help.
Do people ask you a lot if you've found the fountain of youth?
So people say, well, is this the fountain of youth? And now for cells growing in a petri dish, yes, this is one way. If you can maintain their telomeres forever with telomerase, then you can maintain a cell in a petri dish. Now the thing is that real human beings, we have other things that make us have a maximum lifespan. But the fountain of youth also consists of being healthy while you're living. And so I think rather than something to do with pushing out our maximum lifespan and making, Methuselahs or something of us, I think rather than that, our research more relates to delaying, if possible, the major diseases of aging, which are the main cause of ill health as people get older. Not going to put it off forever, the maximum lifespan. I think that is very likely to be a whole lot of other things.
What are the challenges that you deal with in your personal life, and how do you balance that?
Yes. Well, It's certainly very challenging for anybody to balance family and work life, and it's particularly challenging for women, and particularly because of children. And so I found that in my own situation, our son wasn't born until I was actually a full professor, and I found out that I was both promoted to full professor at the University of California, Berkeley, and pregnant, all in the same week. First the professor, then the pregnancy. One of my colleagues said, "How do you think you're going to spend the extra salary?" I said, "I think I know." So in my case, it was rather late in the trajectory of, your life, and I wouldn't recommend this necessarily, but so in some ways the lab was established. On the other hand, there I had a very demanding situation, because I had a very active lab and lots of things that I needed to be doing, and so I had to learn to use time well and juggle, and realize that basically I just didn't do certain things for a long time. So didn't go to restaurants, didn't go to movies, excepting terrible kid movies. So basically I had to become a real problem solver. And that's what I think scientists are good at, actually. So by hook or by crook, I learned that there were just, there were things that you were confronted with that you hadn't been confronted with before. And so I think I sort of fell back on this sense of, well, what was important? And basically there they were. It was family and work, and that was important. And I also realized, somewhat belatedly, that this wouldn't go on forever. So now our son's grown up. And so, you have many, many decades of productive life as a scientist, and your children, they come, they go. There's many decades too, which is when the children are growing up, certainly, of very, very, very busy times. But that was my sense that, you could be very busy, and it's okay. Being tired is not the end of the world. Mm-hmm. And I'm not trying to be tough there, because I'm not trying to say it's not difficult. It was quite difficult and demanding at the time, and yet I always sensed that, my feet were sort of on the ground with respect to, I knew these were important, family and work were important. And so even though I was not necessarily enjoying every minute of it because it was very demanding, I didn't sort of feel I'd strayed in some direction that was not the right direction.
Do you think young women going into science now face the same challenges?
Yes. I think it's much more challenging for women who are more junior going into science in some ways than it was when I did. First of all, my family I started later, and so I sort of felt I had more resources to, say, look, this is the way I want things to be, whereas I think it is harder for young women. On the other hand, the good news is that I think there's much more awareness that, yes, this is important to have women be in science. And I see it institutionally. I mean, people's hearts, I think, really are in the right place. They want this to happen, but there are a lot of cultural things that don't really work in favor of this. But when women do ask for it and realize that it's okay to ask for it and talk among, their peers and, with mentors and so forth, and get support, then I think it is better in some ways than when there were perhaps fewer women in science, and you didn't really feel that you had such resources to talk to. I think the good news is that there's much more of a sense that it's okay to ask for help among peers, and people in general are realizing that it's important not to undercut women's careers in science.
Right.
Not to say it's easy, but I think things have improved in certain ways.
There's still very few women in science, or is there some other aspect that would explain that?
So why are there so few women in what's considered sort of the upper reaches of science, where one looks at senior professors and women who are chairs or deans or something like that, and you see many fewer women than you see men. So what is it about science? And I think that there is a culture of science which it's been very heavily much with men in that culture, and so women are rare in there, and so it's much harder to relate to somebody who's not quite the same as you, and so the critical mass of women is much smaller. So I think that science has really not been especially friendly to women for reasons that probably are similar to other kinds of professions. I mean, there are some professions in which women do well, but if you still look numerically, it's generally the case that they're not represented in as high numbers as when they started off earlier in these careers. I don't know if science is exceptional in that, but I suspect that there are, just cross currents about even how science is conceived of. Somehow it's sort of, there are terms that are much more seen as, traditionally male sorts of terms, and even, the culture of science sometimes has competitiveness to it, which in the older versions of science certainly much more favoured things that traditionally men were more comfortable with. A lot of modern science, interestingly now, is much more collaborative, and I think that's very interesting because now different disciplines come together and together produce, ways of doing things. And so I see that there's certain shifts in which women are really able to thrive because of what, traditional sorts of characteristics women have been, traditionally praised for. Those ones now serve them well in that kind of science. So perhaps if science is changing in some ways, then there will be more interesting possibilities for women. But things like computer sciences, I notice there are very few women, particularly young women even, who are actively in computer sciences. And again, I think that must be a very cultural kind of sort of milieu that makes younger women not so comfortable going into computer sciences. And that's very important for science in general because that's so much part of science.
Were you a part of the women's movement at all? Do you relate with that?
So in the 1970s, I was a student, and so I very much was aware of the fact that the women's movement was, really changing views. I didn't myself go out politically and take active part in events, but I was very aware of it, and I think that sort of had the sense that your actions were speaking, in the sense that if you're pursuing a higher degree and then a career, you're sort of living that out. But it was certainly something that I very much identified with and realized it was very important. And personally, it was important for me because I was wanting to have career options, and the women's movement, which was particularly noticeable in the US, and that to me was one of the reasons why I felt very much that I would have a career in which I could thrive in the US rather than perhaps in some other countries.
Do you consider yourself a feminist, and what does that term mean to you?
Yes, I think in some ways I'm a feminist. I don't like stereotyping, and so I think if you say, well, a feminist is to do with people, living their full potential if they're female, then of course that's exactly what I think is, the minimum that anybody should ask. And so if that's how one defines it, certainly I would say that I am.
Polls show that many women consider ambition to be a dirty word and something not a characteristic they find desirable. Why do you think that is?
I don't know what. I think, again, it's probably because there's been a certain amount of stereotyping in the media where ambition gets equated with, something which is, some undesirable, not feminine sort of ideal. But I don't really know that that's new. I think this has been something pretty old in some ways, that men and women have there's been power struggles over the years, let's say, and so ambition is something where there's a certain threat to the established order that ambition in women might represent. So why, though, this has become disfavored by young women now, I don't know all the forces behind that in terms of why at this particular moment.
Do you see any downsides to the women's movement? In what ways do you see that it's been successful, and in what ways has it left either men in a difficult position or women feeling they have to do it all?
I don't see a lot of downsides to the women's movement. I don't think it's disadvantaged men. I mean, having people who are, more living their potential and doing better and so on, that doesn't seem to be to disadvantage any other group, and it adds, right? And I don't really see a downside to, this idea of, well, you can do it all. And I know. I've heard all the anecdotes and so forth that people say, well, the expectations were so high and the pressure was so high, and so forth. But I haven't yet been able to balance that in my mind with, well, what the alternative was, which was to not have such possibilities. So I think before we get too upset about this, we really should try and do a little comparativeness, because not everything will be, easy. So put it this way, I'd so much rather have had the women's movement than not. And then if we look at the comparison, I'm not sure that I see a relative downside.
What is the one piece of advice you would give to a young woman?
Well, I think the advice I'd give to somebody is don't try and think about balance as something that you're going to achieve all the time, every day, every week. I think more think about balance as something you'll achieve over perhaps decades. You'll have very intense times of work. There'll be very intense times of family or perhaps other things that you feel are important to you. And think of your life much more in terms of, over the long term you might be achieving balance in the sense that you experience different things. But I think there's nothing wrong with experiencing and doing things intensively for, periods of one's life, but not to cut yourself off from the breadth of life at different stages. But it doesn't all have to happen at once.